So you were talking about the right database for the right use case.
Mm-hmm.
And I was just wondering, maybe it's too much to dive into, but like, what are the different databases, like the big ones, I guess, because I know there's a ton of databases out there now,
Mm-hmm.
but what are the different like value props of the different databases? And I
Mm-hmm.
know there's like different styles, right? Like SQL or MySQL and all that stuff.
Mm-hmm. Well, let's talk about Redis, Postgres slash other SQLs. That's the second one. Let's talk about Cassandra, and let's talk about Prometheus as four very different style ones. And there's loads. There's like I wrote two just for fun. They're like, there's one database that says I'm going to save like time telemetry data really nicely, and the other one says I'm going to save calendar dates really nicely. That's what you would class as a very specialized database. It does one thing really well, but it'll do nothing else. So there's lots of those. There's lots of like databases that you can use for one purpose, but the four I mentioned are fairly generic ones, right? So Redis, the value proposition of Redis is it's an in-memory data structure database, or it's actually, in-memory data structure server. What does that mean? It means that if I need very quick access to structured information, Redis is the thing I would use. I wouldn't use Redis if I needed to absolutely guarantee at any given moment that everything is saved right up to the last millisecond, because it's in memory. So what if the power to the computer goes off the next second? Well, bang, everything in Redis just went because it's only in memory. It does keep a log file, but there's the danger that some of the data got lost when you use Redis if it fails, right? What are its strengths? Its strength is incredibly quick because memory is incredibly quick. Uh, it styles itself on having lots of different data structures. So if you needed to do a lookup of this user onto users that user follows, right, then Redis would be a very good system for that, because then what you discover is that's the hot path in your app. That's the thing that all of your users are doing all of the time. And speaking to more traditional databases to answer that question is a bottleneck. That's where you might reach for something like Redis. The common use case where Redis actually gets implemented into a system is as a cache of these bits of information, where the actual information is in another database somewhere that's a bit slower but more resilient. And you say, cool, well, that's a good place for it actually to be the source of truth, right? And then what you do is you load all of that stuff from the actual database and you put it into Redis so that now it's really fast. And so that's an actual kind of how would you use Redis in anger is you use it as a caching layer. So it's a much faster way of getting to the same information. But if Redis went away any second, it would be very easy just to rerun the script that repopulated it with the information from the actual database. So Redis, in-memory style, used for caching, that kind of thing. Postgres, which is an SQL server. So the key thing with the SQL style servers is they promise ACID, which is, I think, atomicity, consistency. I can't remember the other
Yeah, I
two.
heard about that this last
Yeah.
week.
Let me go and remind myself what the other letters in ACID is. Hang on.
I found it quite funny.
Yay, I'm going to Google for ACID. That's going to come good, isn't it? Okay. The obvious other things that just appeared. Okay, so atomicity, consistency, isolation, and durability. So it's basically saying, like, if I tell you that got written, it did get written, and the next second that you ask, you'll get the answer you just put in. So eventual consistency is the other thing. You write some stuff, and then you ask the next second for that same stuff, and it actually comes back as the old value. And you go, oh, that's odd, because I just told you that it's sunny and you're still telling me that it's raining. Whereas literally I just told you it's sunny. And then you ask 5 minutes later and it goes, yeah, it's sunny now. And that's eventual consistency. And the reason that happens is that it's much easier to scale a database that's eventually consistent, right? Because the point is you tell about a new value, and for something to be consistent, it has to tell every place that you might ask about that value. before it acknowledges that that value has actually been written. So Postgres is a good example of a very consistent database. You tell it a value, bang, it absolutely will have that value the next time anybody asks. So Postgres is used for things like banks and user login systems and anything that has that certain sense of structure. It's also quite a structured database. Like in Redis, there's no sense of a schema. There's just different types that you can write. In Postgres, there's a schema. You have to actually define the structure of your data. You have to say, here is hotel review. It's got the user. It's got a name. It's got a price. And you declare, here are the values that I will write. And so Postgres and all the other SQL databases will absolutely check for the values that you write and throw an error if any of those are wrong. So that means that you can start to have confidence that the data in the database has sort of been validated by the database server itself. It's not just throw anything at me and I'll remember it. It's more, I know exactly what you should be giving me if it's a valid thing, and I will not save it if it's not a valid thing. So it's very good for like banking systems. That's what all the banks run on. Is so. In fact, I remember speaking to the guy at Revolut, and they run Postgres. Like Revolut runs on Postgres. So to make a thing like Revolut, Postgres is a good option. MySQL is an equivalent to Postgres. Oracle is not an equivalent to Postgres because it's just a bad bit of software that costs loads of money.
Nobody likes Oracle.
Nobody likes Oracle for good reasons.
But
so,
they're making a ton of money, so somebody's using them.
Yeah, it's almost like the mafia. They rock up with their kind of like, I'm going to make you an offer you can't refuse style. Anyway, different story. We diverge. So I don't think that was a very good description of Postgres, by the way, but let's just leave it as like it's the one that the banks use. Does that make sense? Like there's lots of aspects to SQL and how it works, but the difference between Postgres and Redis is sort of unstructured. It's got data structures in it, but it's not that you define anything up front, and it's in memory, so it might go away any second. With Postgres, it's very structured, very consistent, and it will absolutely be there the next time you ask the question. Cassandra is similar to Postgres in the sense that it works with tables, but the purpose of Cassandra is to be very horizontally scalable and have a high write throughput. That's the feature of Cassandra where you might reach for it, because it's important to consider the nature of your app, right? Is this a situation where things are written a lot more than they're read? Or is it a situation where things are read a lot more than they're written? And that 100% goes into the decision process of what database should I use. Because if something's a lot more write heavy, so for example, a good example of a write heavy thing is like a logging system where you're recording every last event that happened, but probably it's only ever going to be once a month that you need to pluck something back out of that to resolve queries or something like that. That's
like that
a very
Fitbit example.
a Fitbit example, right? It's like, yeah, I'm just going to write numbers all day long, random numbers, almost just a massive torrent of them. What did you actually want to know? Oh, 17. Do you know? It's like, that's a good example of a write-heavy database. A read-heavy database would be like, I don't know, a database of all the atomic elements, right? It's going to be like, yeah, probably, it's good potential that at some point in the next 10 years, we're going to discover a new element. Maybe not, but I don't know my chemistry well enough to tell you the chances. But probably it's not going to be very often, is the point I'm making, right? So that's a good example of a read-heavy database. It's like people are making queries all the time against what the elements are, but we're not updating it that much. So Cassandra is a good candidate for, I've got lots and lots of data, therefore we need to scale, as in it can't just be one computer that this information lives on. Whereas in Postgres, this is a very important thing. Postgres runs on one computer. Now you can have replicas, you can have other computers that are keeping in sync with that computer. But to be ACID, consistent, durable, those other words, isolated and atomic, it's very difficult to achieve those things unless you're running on just one computer. And why? It's a bit like having two. Okay, if you're the boss of running the kitchen, right? It's quite easy to. If you're just on your own, it's quite easy because in your head you've got the picture of the entire world and you know what you're going to do next, and you're now doing this thing, and it's really easy. The moment you throw another cook in the kitchen, it becomes much harder because now you've got to go, oh no, I didn't tell you that, you've got to do this next and hurry up. And you know, it becomes a lot more complicated the moment you have more than one source of truth, right? And the same goes for databases, because as soon as you have two computers that are attempting to come together as one system, there's an amount of coordination, and also the speed of light is a real problem, because you have to wait for the other computer to confirm that it heard that message before you can then acknowledge the write. And there's all sorts of complexities that come with running more than one computer as far as being a consistent database is concerned. So Postgres is a single computer thing. Now you can scale it because you can use read-only replicas, and there's various tricks to having scalability, but it's not about, Cassandra has a totally different model. Cassandra is a horizontally scalable database. It works with sharding. There's that word again, like not all computers have all the data, right? Each computer has a little bit of the data, and then you can ask a question and it'll ask the right computer. And it is designed to have high write throughput. So last one is Prometheus, I think I said, isn't it? And that's very much to do with time series database. So it's very optimized for a sequence of numbers one after the other at certain intervals, right? Because that's a different use case. Now you can quite easily write a time series database, use Postgres or Cassandra or Redis for a time series database. None of these things are like, you can't do what you're trying to do, because they're all general purpose databases that will allow you to do lots of different things. They're quite generic, right? It would be possible to do all of these different things on all of these different databases. But obviously one of them is going to win at certain jobs because it's got characteristics that are better for that particular job. So, you know, let's get time series. And what's a good example of time series? Like application metrics is literally what Prometheus is designed for. But you could also do Fitbit on Prometheus, right? Prometheus, out of all the databases we've mentioned, it would be much more suited to Fitbit than any of the other ones, because it's literally time series database, and it's going, you know, every time you take a step, I'm going to record your location, or I'm going to record your heartbeat, and it just ends up as a big fat list of numbers. And it can then do queries like, you know, add up all the numbers on a Tuesday and summarize them in a graph across weeks, or whatever the query is. It's always going to be to do with ranges in time, and that's what Prometheus excels at.